everybody, and welcome to Leading Entrepreneurs of the World. I'm Stelios Hatzakis, CEO of One Business World. Leading Entrepreneurs of the World features entrepreneurs, founders, and business leaders presenting on cutting-edge topics and the latest industry developments. Today, we're very pleased to welcome leading global entrepreneur, Noor Alnahhas. Noor is a serial entrepreneur with nearly 15 years of experience in the oil and gas industry. He has a proven track record of building businesses and relationships within the Gulf Cooperation Council and serves as an advisor to startups in the Middle East and the US. At Nybl, Noor and his team operate a knowledge-driven machine learning platform that turns mountains of underutilized data into actionable intelligence by replacing data with turnkey intelligence based on subject matter expertise and proven data behavior models. Noor, we're very happy to have you here with us today to hear more about the very interesting and exciting space of science-based AI ecosystems and the transformation of data into intelligence. Welcome to Leading Entrepreneurs of the World.
Thank you for having me, Stelios. I'm really excited to be here today. So I'd like to tell everybody about the story of how we came up with the name Nybl. We were trying to figure out the best way to describe what we're doing as a deep technology development company, playing with the play on words, a pun, and at the same time, getting the soul of the company. And one of our co-founders, Sufyan Abdelhasib, who's our director of deployment, he found the name Nybl. And Nybl, other than the one we know about eating, actually means half of a byte or 4 bits. As you know, 1 byte is 8 bits. So a nibble is 4 bits. So it goes down to the smallest measurable data. So that's Nybl. And the idea is we go to the smallest amount of data to really get intelligence. But let's go even further about what our real vision is. We want to create an ecosystem to basically become the Uber or Careem or Amazon of our industry, meaning enabling anybody who wants to create an AI application to do so. Today, there are a couple of limitations, whether from the data science aspect or managing data or the data itself, the historical training data, the models, even the go-to-market strategy. And so our goal is to create that ecosystem that allows anybody to come in and configure that. But why would anybody choose Nybl? Why are we different, or why are we better? Because a lot of the big companies in the AI world today offer such platforms. But first and foremost is we are smarter AI. And that's because we use science-based artificial intelligence, which means we've replaced historical training data with what we call science, turnkey, subject matter expert modules, and data behavior models. And I'll talk about those in a bit. And that means there's no other solution that works like ours today. Beyond us tooting our horn, the reality is we designed our system to be limitless in application. So we've done already applications in oil and gas. We've done applications in healthcare, which we'll talk about today. We've also done physical security. We're looking at working in farming and insurance. And above all is, even though we're making some wild claims, our system is proven. We have governments, multinational companies, and national oil companies all relying on Nybl technology, and we've only been around for 2 years. So imagine where we're going. But what do we mean by we're better or smarter AI? Well, first, we do it better, meaning whenever we develop an application, there is no need for upfront initial costs and data or data scientists. So our intelligence platform replaces historical data by us pre-developing and pre-training the model using science and data behavior models. And I've said that a lot now, so I'm finally going to tell you what that actually means. So what do we mean by science-based AI? In traditional artificial intelligence, right, we identify an event or something we want to predict. So let's take the case, for example, a failure in a pump. And before we can get to the AI, we have to do the machine learning aspect of it, right? And so we would tell a client or whoever wants to, we need to predict for saying, all right, we need 10, 20, typically 100 or more data sets of 3 years of information so we can analyze and run the data science models, meaning regression, clustering, nodal analysis, you know them, to get the outcome, right? And that is, it tells us here are the feature values, and we're going to predict, here's how you can predict, and here's what you can predict based on historical data. So there are a couple of challenges with this traditional method. First, you have to actually have the data. There are many industries that may not have the data. Second is you've got to spend a lot of time and money in preparing this data, and that's running QA, QC, feature value labeling, and then processing the data. So you've got to make a lot of investment upfront before you ever know what the outcome will be. This is one of the challenges. But the more important challenges are that we've seen many times what's called correlation without causation. So, for example, one of the best examples I remember is you can actually correlate the divorce rate in a state, I think it's Idaho, in relation to the consumption of margarine. Now, we know they're not related. Maybe they are, and people are getting out of control and consuming too much margarine, getting divorced, but reality is most probably those are not the causation. The consumption of margarine is not the causation of divorce, but there is a correlation. And running standard data science doesn't analyze causation, just gives you correlation. So this is one major one, and then which tends to lead to the second thing, which is what we call bias. And so that means traditional models running traditional AI data science will give you bias to the historical data you trained it from. So how do we eliminate this? We've taken out historical training data, and we came to say, how can we replace? Well, first we need to teach the model the principles of what it's looking at, and then we need to teach it the things you would learn from analyzing historical data. So we started by teaching the model using science, meaning the physics or math or facts of an event. So you may think, well, this may only apply to process, but no, we've done this in supply chain, physical security, in everything we have in life. There are rules and facts that we know exist. For example, in a pump, we know the laws of conservation of energy, momentum, mass. We know laws of thermodynamics. We know laws of hydraulic simulation, whether steady state or transient. In security, we know the rules of a building security. These are facts. So this served as creating what we call a digital twin. This is the first step, but it didn't replace training data yet when we were building it. So the second step was saying, well, now the system knows hard facts. We eliminate bias. We understand how something can function and should function, but how do we teach it what we learn in depth? And that's where we built something called the subject matter expertise module. And the subject matter expert model is teaching the model further about a specific application. So if we take a pump, for example, we know the relationship between pressure, temperature, and flow. So we teach it that. We know the relationship between intake pressure and discharge pressure. In security, for example, we know the rules, the relationship between computer vision analyzing somebody's face, and if they're angry and holding a gun, that's not a good thing. So we've built a very complex matrix that we call a subject matter expert model. And that helps the science, the model, make sense of the science. But until that, we still hadn't achieved the full model. And really, it was when we came up with the data behavior model, which was our aha moment, that we totally replaced training data. And the data behavior model is a concept that the behavior of data is more important than the actual value of data in making a prediction for us. Meaning, we don't care whether a pump is at 1,000 PSI or 1,500 PSI. We care about that delta. Did it jump from 1,000 to 1,500? Did it jump from 1,000 to 100? And the same with behavior and operations. We don't care whether a door is open or closed from a security perspective. We care if that behavior is normal. Have we seen it before? And so what we're analyzing in a data behavior model is magnitude, recurrence, and consistency. Now, what's really cool is that our engine is determining over what time period to analyze this data on its own. So the AI engine is determining for a very volatile operational environment I may want to assess on a much more sensitive period or a much longer period. And for a very steady, non-dynamic operating environment, I may want a shorter period. So all of this done. Now, when you combine all of these three, the science, the subject matter expertise, and the data behavior model, and we feed it with real-time data, that's where we get science-based AI. So the outcome is a subject matter expert or science-based artificial intelligent engine that actually understands the subject it is predicting or managing and is running in real time. So we're not analyzing after the fact, we're running in real time. And what that creates is a real-time predictions in both operational and in failure. And we'll talk about all of the actual components of what we do. But if we want to talk about how this is actually being done from a machine learning perspective, we run two unique and independent systems. The first one is an unsupervised machine, which we call our prime engine. And the unsupervised machine is the one that's tying the domain knowledge, the scientific models, the data behavior models. So those three things together. And so if we take a step back and remember the difference between supervised or unsupervised machines. An unsupervised machine is not told specifically what to look for, but given a set of circumstances to function and identify from within. So if we take a step back, if we wanted an unsupervised machine to look at a picture and identify whether the picture was of an apple or an orange, the unsupervised machine would just be told the constraints, meaning apples are round, they're generally red, maybe green, could be yellow, they have a stem, they might have a root, and so on, and the peel is smooth, that kind of thing. In an orange, for example, is round, the peel is bumpy, it's color orange, and so on. And so the unsupervised machine assess all of these things it's told and predict whether the picture is of an apple or an orange. And a supervised machine, on the flip side, is told specifically what to look for, meaning it's given pictures of apples, pictures of oranges, and it compares what it's looking at now versus the pictures. So it may have an apple in front of it, but if the apple in front of the machine, of the supervised machine, is not the same as one of the pictures, the machine won't be able to predict that it's an apple. So what we've done is created the main engine as an unsupervised machine to avoid this miscategorization. So the domain knowledge, the scientific models, and the data behavior models all together give predictions. And the type of predictions we'll talk about next. What happens though is once we give those predictions and we offer feedback to the machine, we create supervised machines. So for example, the system makes a prediction that a pump is going to fail. We take action, whether or not the pump is going to fail. If the prediction was correct, so we could validate that this pump was going to fail, we feed the system back saying, correct, the prediction was correct and your failure causality method is correct. Now the system creates its own independent supervised machine that will now look for this specific scenario model independently. And now all of a sudden you have two parallel machines, an unsupervised machine looking for everything it's been taught, and a supervised machine that's looking for this unique scenario model that's already validated. So imagine what happens over time. You start getting a system that's more and more and more intelligent with very specific supervised machines while still having this overarched unsupervised machine. And we've actually got several very proven successful case studies that I'll share with you that show how this model works. But how does this actually work? Well, it all works within our tech stack. And the first thing I want to talk about in our tech stack that I'm really proud of is the fact that you don't see a single third-party logo. Most technology companies in their tech stack show you all of the different third-party software that's being utilized. In actuality, every single part of our software is completely developed by Nybl in-house, starting from interchange, which is the engine that collects the data. So we're able to collect data in real time or in batch from devices, software, databases, hardware, you name it, and we've connected to everything. And then pass that in data onto our database. The database is a totally decentralized big data database technology that can do both structured and unstructured data. It means we can do text, data, video, audio, pictures, all the different types. Now, here's the really cool thing about our database is as the data moves from collection into database, it's goes through a QA/QC. So we do the quality analysis and quality control, and we reject data that doesn't make sense. And it's feature value labeled. So for everybody in data science knows that those two things are some of the biggest costs in preparing data when you want to run data science exercises. So even though we don't need data science, what we're doing is creating a platform of data for our clients so that even if later they want to run, and we would run as well, data science exercises on those like regression or clustering, the data is prepared. So it's feature value labeled with a quality and integrity meter in the data, ready for consumption. And then this is where the magic happens in our intelligence components, where the data is consumed. If you see each one of these components in blue here, every one of those is an independent system. Imminent event prediction, future event prediction, those are their own networks. Computer vision is 53 concatenated neural networks. So it's built on the concept of YOLO, you only look once technology, but it's built forward. So you have 53 concatenated neural networks. Look at computer vision. Computer audio is the same. Now, what's cool about this is each one of these modules is fully developed already. And when it comes to an application, all we do is configure the science for that application. So we're going to talk about the applications we've already done in oil and gas or in healthcare. But all we had to do is configure these components and assemble them together for oil and gas. So for example, lift.ai uses imminent event prediction, future event prediction, anomalous and others, but doesn't use computer vision yet because it's not necessary. Our See and Shield, our security product, uses all of them, but also uses computer vision and computer audio. And what that means is for any partner or any client that comes and says, well, we want to predict this, or we want to be able to identify that, we're able to mix and match from our components and configure them for that application, which means timeline out of window is exponentially faster than a traditional process where you may spend just months in the data analysis. Now, once all of that's done, it goes to the only part that end users see, which is our interface. And we've got everything from web to iOS, Android, thick, thin clients, and we're using, and all depends on the application and security. But most importantly, all of this is managed by our protection layer. And our protection layer is multiple levels of encryption. Both the data itself and the transmissions are encrypted. So even if somebody is able to intercept the transmission, the data itself is encrypted. So it creates a level of security that's met all of our clients' cybersecurity standards. So this is the Nybl tech stack. It's actually one of the things I'm most proud of our team and our company, because we control every aspect of the technology, which means we're able to deploy on the cloud and on premises, because we don't need to call on cloud services to run any part of our technology, where a lot of companies may have to do that. So where do we do this today? We focus on three main verticals in oil and gas, in industry, sorry. In industry, we have applications in oil and gas. We have application in physical security for industrial areas, and we're looking into applications for agricultural technology. In commerce, we already have the smart supply chain and smart inventory product, and a very, very cool new product that we'll be announcing very soon in consumer behavior that I'm really excited about. And then in finance, we're working on helping companies look at insurance front from a medical perspective and credit worthiness for institutions, so companies. How can banks assess credit worthiness for large companies? And all of this is from the hard work of our team and has got us to this point, which is These clients, thankfully, some of the biggest names, like I said, governments, multinational companies and national oil companies, but also, I have to give a big shout out to the Dubai Future Accelerators, who were really the accelerator that jump-started our company. They gave us all the support. We've been through two cohorts, cohort 4 and cohort 6, and as a result have both developed our tech even further and achieved a lot of success with a lot of partners and customers because of the support. So I have to say that's been an incredible advantage for our organization to be based out of the UAE and the support of the UAE government and the Dubai Future Accelerators. So what I'd like to do is tell you a little bit more about some case studies so you can really understand the value that this technology can actually do, and that we're not just claiming some wild claims. We've got two very cool case studies, one in oil and gas and one in healthcare and supply chain. So our oil and gas product is called lift.ai. Lift.ai is a failure prediction tool applied for artificial lift. So artificial lift are pumps, as you can see in the picture here. These are the pumps that remove oil from the ground. So sometimes oil doesn't flow naturally, and companies have to put in artificial lift equipment. So lift.ai is our artificial lift management product. We do both monitoring, control, optimization, failure prediction, and failure prevention. So in this case study, we applied our lift.ai tool on ESPs. So ESPs are electrical submersible pumps, and those are pumps that are actually down underground and they pull out oil. And the challenge with ESPs is that while they don't cost a lot of money in relation to the cost of a well, if they fail, it may take 90 to 180 days to replace them. And that means for 90 to 180 days, there's no production. That is a lot of money. And so the ability to be able to know when a pump will fail and prepare accordingly and take proactive action is extremely valuable. So we ran our pilot on 27 wells onshore and offshore, and we're able to provide to the client proactive management, a reduction in downtime, increasing the pump life by optimizing the operation, and actual increase in production. So we were able to actually, and we can't divulge the numbers, suffice it to say it was humongous, 5% increased production. And to put that into perspective, in oil and gas, a 1% increased production is significant. We were able to reach up to 5%, extend the life of the pumps by 30%, and we actually predicted 3 out of the 3 failures. So during this time, 3 pumps failed. We predicted 3 of them ahead of time. And I think at the minimum of 30 days, some of them before, more than that. So we were able to give them minimum of 30 days notice that these pumps are going to fail. Extremely successful case study. And now because of that, rolling this technology out with a lot of different companies. The second case study is an application for our supply chain. So failure prediction applied to inventory management and planning within our smart supply chain. And I can say we did this with the government of Dubai because it was part of the Dubai Future Accelerators program. So this was actually one of our biggest outcomes of that. And the challenge was to reduce the time a government employee spends on planning and in inventory management, purchasing, and planning. So the first process of the project was a digital transformation. So moving from a manual process into a digital process. And then the second step was moving from a digital to a fully AI process. And so the outcome was real-time, dynamic, AI-driven min-max planning for inventory, AI-based inventory demand forecasting, and automated purchasing from AI. So we would decide the minimum and maximum AI. We would then forecast the demand, plan accordingly, and place the purchase orders in using all artificial intelligence. And the outcome was we saved the client 85% time in inventory planning and purchasing and 88% time reduction in inventory management. So they were saving over 6,000 hours a year, every year, just from deploying this software. So those were the two big case studies that I've put together. And I hope that what I've given you is a good insight into Nybl and our technology and the unique approach we've taken to replacing historical training data with science-based AI. We're very excited about where we're going, and we invite anybody who's with us, who's interested in deploying, building on Nybl, or even joining our team, to please reach out. We'd love to hear from you and see how we could potentially work or work with you, or help you out and work for you.
Noor, thank you for the presentation. Incredible work you guys are working on, leveraging smart science-based AI to turn knowledge, data into knowledge, and also prediction. Incredible machine learning platform, real-time analytics, science-based AI to the next level. As you said, through science, data, behavior, subject matter expertise. Noor, you spoke about the some of the Nybl solutions for different applications like lift.ai, supply chain AI, incredible solutions and undoubtedly very value adding. Could you tell us a little bit more about how companies can build their solutions on top of the Nybl platform and market their software under their own brand?
Absolutely. So, deploying our own verticals was a necessary step because we're making a very unique claim. So we wanted to show clients that it works. But the vision is to allow, just like you said, for anybody to deploy using our tech. So the way it works is we have what's called an enterprise master license, and a company would come to us. For example, let's say somebody in healthcare that wants to predict a diagnosis of something specific. They would come to us and say, this is what we want to do. The master license means we work with their subject matter experts, or we bring people to configure or learn the science and the subject matter expertise. We configure that into our platform, and then that client takes to market. The best example of that is the CN Shield product. So Comtel Networks is actually our first client and our biggest investor, and they are the first company that ever master licensed on the product, and they are in the security systems integration. They wanted to build an artificially intelligent physical security system. And so what happens is we get together, we explore the where AI can be applied to an industry. We identify the unique values AI can provide. We identify the leap, the generational leap, as we call it internally, which is we're not going to just deliver something that matches what's being done, but it's a generation ahead. And then we configure the system. For example, a very complex system like the CN Shield security system takes about 6 months to configure for the client. But others that are not as, because we had multiple data sources, video, audio, sound, system access control. But in things like we're looking at in insurance or in finance, it could be as quick as 6 weeks that we've done some as well. So the first step is identifying what they want to do, and then we work through it and give them the ability to roll out on our network. And they can host on their cloud. We can host it for them, where it's very flexible in the model of the way it's applied.
Absolutely. This is good stuff. And then, Noor, you touched upon the limitless nature and expandability of the Nybl solution. Could you tell us a little bit more about how expandable Nybl is to be used by different companies, different applications from within different industries and regions? And maybe you could also state a few key reasons why the use of science-based AI for data analytics and intelligence is key for high growth companies from within different industries.
That's amazing. That's a great question, Stelio. So let's talk about scalability, and it talks both about, this first point answers both questions. The challenge usually with scaling very large AI systems is you need to run the data science to keep feeding the algorithms, okay? When we go to a science-based system, we do all that work one time up front. After that, it's done, the system keeps learning, okay? So for example, lift.ai is a product that's been developed. It rolls out now from client to client. Now we continue working because we build new stuff, but the Lift AI application does not need to be modified or does not need to be relearned or retaught for every client. So when you take that into perspective as a company that's scaling out a technology, rather than having to have an army of people to replicate a solution across multiple clients, it's one team. That's it, the product is done. From a technology perspective, the system is truly scalable because every component you saw in the tech stack, intelligence, database, interchange, each one of them is a fully independent software code. It's an independent program. So really, we haven't developed one program. We've developed 4 programs: intelligence, interchange, database, and interface. And what happens is when we scale, the system dynamically increases the number of modules it uses. So I'll give you one example. In one test we did, we tested on one well, so we had only 10 points of data. Very easy, anybody can handle that. But then scale from one well to 987 wells. So that's 10 times 900. So you have almost 10,000 data points coming in every minute or every second into the same system. It's capable of handling that. We've actually stress tested up to 3.5 million data points on one server. So now that means in one module, if we need another 3.5, another 7, another 10, another 20, another 100 million, we just replicate the number of modules that are running. And we've proven that. I mean, we're running hundreds of thousands of data points every second through our system today in everywhere from oil and gas to supply chain. So that, I think that those answer both. One is in the scalability from a technology perspective, and then the scalability from the people perspective for companies. So why would you want to use the tech? The one last part is about industry, and that's where it's interesting. If you saw in the tech stack, we talked about imminent event prediction, future event prediction. That doesn't define an industry. Imminent event prediction for oil and gas is failure for a pump. Imminent event prediction for supply chain is a shortage of a specific item of inventory. So those are the engines we've developed, are these components. Configuring them for an industry is just the 20. So I was like, we've done the 80%. Now we do the 20% to finish for the actual application. And that's what makes it so easy to scale to industry, to scale in size, and to scale as a deployment as well.
Noor, thank you very much for your time, your participation, and your presentation of the Leading Entrepreneurs of the World series. You and your team are doing a fantastic job with unique value-adding solutions that help businesses get to the next step on their growth journey. Thank you, and we look forward to speaking with you again soon. Great work.
Thank you very much. Thank you, Stelios. Thank you, guys. Thank you. It's been a pleasure. Bye-bye.